Now, we've talked mainly about the space, so we'll talk about the conductor a little bit. Copper foil is produced by electroplating process, and it's where we carry the electrons on the surface. What's important is the copper foil has two sides. One side is the shiny side, and one side is the matte side. What's critical about this is the bonding side is designed so it sticks to the resin, so it doesn't fall off. So it has little sort of cauliflowers all over it. So that's the smooth side on the left, that's the rough side on the right. The real problem is how much that treatment is. So that rough bit on standard foil is up to 10 microns. The copper foil itself, by the way, can be 17 microns or 35. So it can be, approaching half the thickness is the roughness. Low profile foil is 5 to 9.9 microns, and very low profile is less than 5 microns. So that's where we are in terms of standards for copper foil. You think, well, so what? It doesn't really matter. Well, it does matter, because when you come to high frequencies, of course, electrons tend to flow in the surface of the conductor. So there's so-called skin effect. There's an equation here to show you where the electrons flow. But basically, the higher frequency you go, the more they go to the edge. And you can calculate from this equation how much skin you have. So I did this, and I calculated at 50 hertz, we've got 9 millimeters. So we're talking about a conductor that's 17 microns, so no problem, we can conduct everywhere. At 10 gigahertz, it's less than a micron, which is a bit of a problem, because our foil profile can be 10 microns. So actually, you end up with 10 megahertz, no problem. The electrons can tunnel straight through the material. You go to even 100 megahertz, the skin depth now is 6.6 microns. So on the surface, we're fine. On the shiny side, the rough side though, we've got 10 microns of gaps now. So actually, the electrons have to go up and down, up and down, up and down. That gives us some problems. You've first of all got a higher resistance, because this side of profile treatment has different metals in there as well. So it's not just pure copper, you have zinc in there as well, and other elements. And also, you've got a longer signal path. So when electrons travel down this, it's pretty messy now. It's not all traveling at the same speed. So that is really a major factor when it comes to signal integrity. So again, ways of mitigating that, I suppose, to some degree. We can go to what's called ultra-low profile foils. You can now buy copper foils with profiles less than a micron. You can also get foils that are called almost no profile, ANP. So I'll pass a few of these around just for interest as well. So these are some examples of copper foils from the only producer left in Europe, sad to say, which is now owned by Doosan. So these are just some ideas. So again, copper foils have been developed over the years from this 10 micron profile down to sub 1 micron now, just to allow for this. So copper still works, but there is a challenge now.